2015 Facilities Geospatial Technologies Showcase. This 6-month webinar series is hosted by the Campus Facilities Technology Association and organized by the University of Kentucky. I'm Lauren Weaver, and thank you all for joining us today. Today's webinar is being recorded. Both the recording and slides will be made available on the CFTA website following this presentation. The presentation is estimated to run about 45 minutes with the remaining time dedicated for Q&A. So please send any questions you have during the presentation using the questions box or by raising your hand. Your question will be added to the queue and answered at the end of the presentation as time allows. I'd like to extend a big thank you to today's presenter, Aaron Chevrant. Aaron is the CAD and GIS Manager for Information Services at the University of Washington's Capital Project Office. Aaron will share some of his experience with implementation of a facilities information spatial data model. The University of Washington maintains floor plans in a CAD environment, which then syncs with the GIS hourly, and lately with this connection, interior and exterior areas of campus are navigable. Aaron, thank you for joining us today. The webinar is yours.
Thank you, Lauren. Happy to be here. It's been a great showcase so far of other universities, and I'm very happy to be able to participate. So I think you did most of my presentation already. So I'm going to talk about the university's implementation of the Facilities Information Spatial Data Model. I'm actually part of the group that's helping to define this data model, along with some folks from Esri, PEM-based solutions, and Vertex 3. We definitely welcome any and all comments and feedback, so if you have anything, get a hold of one of us. I think there's some contact information on the FISDM website. Let me get to my presentation. Here we go. So I'm the CAD GIS Program Manager. As Lauren said, I'm in the Capital Projects Office, so we manage all the capital construction for the university. My team is actually responsible for a variety of things. We manage the CAD standards for all capital projects, and we also do enforcement of those standards through CAD compliance reviews for projects. We also maintain all of the building floor plans, the basic architectural floor plans, convert those over to GIS, as well as do some mapping to support a variety of university needs. Some stats on the screen, decent-sized university. You know, one thing I found really interesting with the polls is it's talking about a campus, but we are a very spread out organization. We have campuses actually all over the world, and so looking at just the Seattle main campus is the bulk of the space, but we do have quite a bit of space throughout the state and the rest of the world. So a bit of an outline. I'm going to go into what actually is FISDM. Look at some of the tools that we've put together to support FISDM implementation. Look at the actual database itself. How do you actually use FISDM? That's been one of the real challenges in the past, is how do you actually use all that data once it's in there, and there's definitely some challenges with that. Looking at our new navigation system, we are hoping to release that any day now, working through some logistic issues, but give you guys a bit of a preview on that. And then what else can you do with FISDM and expanding that to be able to do other things. And then of course some pretty pictures at the end. It's going to be generally a pretty technical presentation, so not a lot of pretty pictures along the way, so I figured I'd throw some in at the end. So FISDM is really a pragmatic approach to GIS for interior space. It's really not just an academic exercise or a thought exercise. This is based off of years of use of GIS for interior space and addressing a lot of the shortcomings of previous attempts to do interior space GIS that weren't really fully thought through in how it's managed and maintained and then used. So we're trying to address a lot of that with the new FISDM system. It also contains not only the data model, which has been there in a variety of formats for some time now, but also some templates and tools to move data around and actually use the data itself. I do highly recommend checking out at FISDM.org. Like I said, there's a contact page there, as well as you can download all the sample stuff that's there and get started. So I decided that I was going to wrap this whole presentation around the use of FISDM in terms of our navigation system. So we have a new navigation system that's going to be coming out soon. It's all built on that core FISDM data model along with some local government things. Talking about FISDM in and of itself, it's really the backbone of any interior space system, but in and of itself, it doesn't do a lot. So what do you do with it? So this is an example using it for navigation. There's a lot of moving parts in it. I'll kind of break this down piece by piece and go through it. I don't have a lot of time, so I can't get into a lot of details, but there are actually a variety of resources that get into further detail in each of the sections. So let's take a look at the source. So for us, we use CAD drawings as our source, and I've developed some tools to support the CAD management and from a CAD user perspective to prepare CAD drawings for GIS, which is a bit different, I think, than a lot of other GIS approaches in that we're focusing on the CAD side of things and how the users have a process to support GIS, because natively CAD isn't real intelligent, but it needs to be in order to work with GIS. So our core system really is the floor plans. That provides the basic foundation for everything. Of course, we don't want to have our floor plans in feet or geo-referenced, natively, because they become really difficult to use on a day-to-day basis in a CAD environment. And we still need to use CAD for a variety of things. So the floor plans themselves all have a local coordinate system, 0, 0 is like the lower left corner of the building or the grid intersection or something like that. And then we relate that to a geo-reference site plan, and for us it's usually a state plane coordinate system. And then we use that relationship between those two drawings to create a world file, and that allows for geo-referencing. And I've got some code in CAD that'll create the world file. It'll help prep the drawing, and you can see that if you look at one of the floor plans from our catalog, there's actually some additional feature classes in here besides just your standard point, line, polygon feature classes that CAD typically has. And so that provides the data that GIS can consume, and it really becomes a feature class to feature class translation instead of a CAD to GIS translation. So with our routing system, we didn't really need to do a lot of that feature class creation in the CAD environment because it's really, really basic line work that we have in CAD. And so we're able just to use the standard CAD feature classes and use layer filtering to be able to get the data we need out. All of the routes are done in 2D, but they do convert over to 3D. So I'll take you over and show you what that looks like from the CAD environment, or from viewing the CAD from the GIS environment, I guess. So here we have some site plans. So here's our base map that provides our reference. We have an outline file that contains a variety of different building outlines. So we can have a roof outline that's associated with the architectural floor plan, because we have an architectural roof plan, and so they're perfectly aligned. It's all based on the geometry in the roof drawing. But we also have a variety of other building outlines, like foundation outlines or even a symbolic outline, but it's all related to the spatial location and orientation of the floor plan. And so it lines up with all the interior features very, very well. So if we look at the first floor, this is actually native CAD drawings and those 3 feature classes directly from the CAD drawing. And because there's a world file in that folder, it automatically geo-references it. Now you also see that there's some data or some feature class groups in here. So I have the first floor and the second floor. And this is really where we start to get into managing and using the interior space data and some of the challenges that we've had in the past with having to create multiple layer groups and be able to turn things on and off. And that's something that we've kind of resolved with some of the FISDM functionality for using. Now we've got our source data ready to go. We got to get it in. So we use a product called the Sync Engine from Vertex 3 or Gizinta. Steve Grisey, I've been working with him for a number of years on developing this, and it's a highly customizable or configurable system that allows you to kind of have any sort of input and map it to any sort of output. So for us, it really comes down to our input is our CAD drawings that live in our document management system. Primarily it's CAD drawings, but we do have some BIM things that we're trying to experiment with. I've run into some recent licensing issues with Autodesk software, which some of you may have recently run into as well, if you're an education institution. So we finally have new licenses, so we'll hopefully get that kicked off and started back up soon. So in our document management system, we have essentially two main categories of data. We have all of our data that we create and maintain, so our floor plans, our building outlines, and our base map. And then we have another set of data, which is our archive. So anything that's put into the archive are things that need to be removed versus everything else that is live data that either needs to be created or actually updated in the GIS database. So the real brains behind the whole sync engine is the config files. It's a set of XML configuration files that are able to map the CAD inputs to the final database outputs. And there's a variety of config files by kind of drawing type. There's actually a sample process that's available from FISDM that works with the Floorplan GIS defaults. And so if you have some CAD drawings you want to test this out with, it should work out pretty well. I think the only thing you have to do is configure the Floorplan GIS config file to match your CAD standards. Once we have those config files in place, there's an hourly process that's kicked off through a scheduled task on the server that will read all of the changes to the CAD drawings and run those through FME using the config files to determine all of the things that need to happen, a bunch of QA, some spatial operations, deriving additional data from the source data. And it puts each floor into a staging database and does some QA on that. And then it compares that to the master CAD database and finds any differences for that floor between what's coming in and what's already there. And so the changes that actually get updated in the CAD master database are only those changes that need to happen to synchronize with the current CAD drawing. So we're not doing a full floor replacement. We're actually doing per room and per feature updates to the master CAD system. Once that's all done and the Python processing is complete for the whole list of drawings that have changed, the master CAD database is then synchronized with the production GIS database. So here's a look at kind of during the process what happens with Gizinta. So we have our outline drawing here as well as one of our floor plans. And here's one of our feature classes in the building outlines, which is what we call our building outline tilt. Is basically just a square wrapper around all the architectural lines with an offset of like 10 feet. And then we have our floor plan lines. So all of our architectural lines are walls, doors, windows, things like that. We also have some interior spaces, so our rooms. These have data, so the building, the floor, the room IDs, all those sorts of things. There's no space information about room use. That's handled by another system, but it does have all the key data to go along with the geometry. And then, of course, a floor plate to go along with that. So that's all that comes from CAD. Now, we actually use a lot of other feature classes that are derived from that. So we take that four set of features that come in from the CAD drawings, and then we actually extrapolate those into a variety of other things through some FME processes. So here we have an outline point. So we also create kind of a shrink wrap around all the architectural lines for some other interesting purposes. And then we also create a floor outline point, which centers in the middle of the floor. We have a floor hull, so it's that shrink wrapper sort of thing. We also convert the architectural lines into published lines. So one of the things that we found a while ago was the rendering performance on the architectural lines was absolutely abysmal. There are so many features in individual entities that come from CAD that just the rendering and processing of all of those individual features just takes forever. And so what we found was that by aggregating those into one feature per floor, the render time is vastly improved. And so we can actually render, an entire floor across the entire campus, it's like all the first floors across the entire campus at once, and it renders very, very quickly. We also do some interesting things with basically creating like an isometric view of interior space. And then, of course, we also create some room points that can be used for a variety of purposes. All right, so now we've got that into the database. What does the database actually look like? So here's a template of the actual FISDM data model that you can get and download. It does follow the local government naming system, but it is organized a little bit differently and has a few other features in it. Looking at it from an interior space perspective, it makes a lot more sense to have, kind of a core floor plan data set that provides all of your, kind of what I call the new base map is the interior base floor plate reference data, and then also the, your overall base map for campus. There's also some templates in there for assets. We haven't gone into a lot of detail about template assets or prototype assets, having fire alarm systems or plumbing systems. It's really just kind of some template feature classes to help you get started with creating whatever you need based on the data that you want to have. So taking a look at what we actually have so far, and we're still in the process of fully implementing this. I keep running into issues where I don't have enough time in the day to get everything done. But we do have quite a few additional feature classes that we put into the system, as well as some data sets for some projects that we've already had starting up. But one of the more important things is the methodology that we've used to address kind of a common issue of, I have data, but the data lives in another system. We have CMMS, we have a separate space management database. They're not directly in GIS, and they never will be necessarily. But we need to be able to bring that data in and merge that with the geometry to be able to create, an actual facilities information system. And so what we do is we use a remote database connection to be able to pull the business data from those source locations, and we create a spatial view of that with the geometry that we want to join it to, so like the interior space, and then we publish that as kind of the real feature class that people would actually use. So when consumers grab that data, or the feature class, it already has all the data with it, and they don't have to worry about doing an ArcMap join or anything like that, which can cause some problems and requires a higher level of sophistication for the users. So we do a lot of this on the back end to make things a lot easier on the front end. All right, so now we've got some data in there. What do we actually do with it? And this is actually, I think, where it really kind of comes together and becomes something that's actually useful. The main thing is being able to filter data. With interior space, you always have floors overlapping each other. That's probably a little bit different than most GIS environments. And so we've ended up using data-driven pages in ArcMap to control the for filtering, so we don't have to create those different data groups and individual layers and do a lot of definition queries and checkboxes and things like that. And ultimately, once you get to a certain number of those in any one map, it just becomes so unwieldy that you can't use it anyway. So data-driven pages allows you to programmatically do the filtering, but it also allows you to do some really cool other stuff, like be able to rotate the data frame so that it matches the building and not just true north is always up. Everything for this does key off of the floor ID, so all of the data that you want to filter has to have a floor ID. But other than that, it's pretty straightforward. Right now we're using floor points to define each page index, but we're also looking at having a polygon layer in addition to that, because in the extent view, you can look at it, you can set the scale either by an attribute field, or if you have a polygon, you can do kind of a best fit. So it gives us a little more options in different page layouts. So this is actually what the index looks like. So all the points are individual pages in the map book, and each point has the floor ID, it has building name, floor name, it has rotation, it has a variety of different scales. So you can have kind of 11 by 17 scale or an 8.5 by 11 scale to match a few different page layouts. Now, actually editing data related to floor plans becomes a challenge, because you always have to assign that floor ID in order to filter the data. And using the Esri Attribute Assistant has been a huge benefit in automatically assigning that, because one, it's just done automatically so it's faster, but also eliminates any sort of typos that may happen by, after you key in so many things over and over again, you're going to kind of mess one of those up, and so that alleviates that whole process. So I thought I'd go in and actually show you what that looks like. So here is the building that I'm in, building number 1027, and up in the data-driven page toolbar, you can see here's the floor ID. So this is my building ID 1027 and floor 01. And if I go to the next page, I'm now on the second floor, and it's automatically doing all the filtering. I don't have to have a bunch of different layer groups. I can have one feature class that has every room everywhere and do symbology on one layer, and it's going to be consistent everywhere, and data-driven pages will actually do the filtering to show me just that one floor at a time. And you can also export this either to a PDF or print it, and print as many pages as you want at once. So you don't have to go into multiple maps to print. You can just hit print once, and I can literally print all 1,600 pages if I wanted to. I don't recommend doing that. It takes a while to do that. But let's take a look at the routing drawing. So here's the routing network for this floor as well. If we go back to the first floor, you see it's a little bit different. When it comes to editing, this is where it gets real interesting. So I've got a point of interest feature class, and this is actually what we're using for our navigation system right now until we get InVision up and running, is I can go in and edit features, start editing. And right now I don't have any points of interest, but I can easily say, well, I want a landmark in room 209, which just happens to be my room, and we'll call that Aaron's room. And you can see that it's actually assigned the building ID, the building name, which is wrong, different issue, but the floor ID, the room ID, and this all runs off of a database table that's configurable, and you can set that up to match whatever schema you have or define what programmatic changes and data assignments you want to have happen. By contrast, if I turn Attribute Assistant off and try and place a point, it doesn't show up, and that's because none of the data has been assigned. And this map is set up so that the point of interest layer is being filtered per floor. So without that floor ID, it's not going to show up. So if I turn Attribute Assistant back on and I go and edit that, let's say I just move that to another room, it's now updating that data and putting the floor ID in there, so it's now showing up. And every time I move it, it'll recalculate that data and update it correctly. So there's a lot of power in that, and you can really add a lot of data very easily just by digitizing using ArcMap and having all that data automatically assigned. All right, so as I said, we are working on implementing InVision FM from Pen-Based Solutions. This will be a partial replacement for ArcMap. It'll provide a much easier interface for a lot of people to be able to do data edits, both tabular data as well as geometry edits, so moving points around, things like that. And it also does a lot of automatic data assignment to associate things to floors, and it does have floor filtering capabilities in it as well. So there's a lot of capabilities with that we're really looking forward to, and I just need more hours in the day to get it up and running. All right, so I think we're going a little quick, but we'll leave lots of time for questions. So let's take a look at the actual navigation system. So here is a view of a building that's kind of mid-process. It's kind of it's an inspection view in the FME translation to kind of preview what it's going to write to the database. And there's a lot of things going on here, but as I said before, all of the routes are drawn in basic 2D CAD, and we use a layer assignment to determine the elevation. And by doing so, we're able to get not only the floor elevation, but also model the stairs correctly. One thing that we don't have in the CAD drawings are any real definition of elevator route geometry. What we actually end up doing is all of the elevators have a specialized room name. There's an EL in there, and then the car number. And by using the room points, that's kind of one of the derived derived elements from the rooms, we can use the room number and filter that and say, well, show me all of the room points that are elevator room points for this car number, and then with FME easily string those together into a pure vertical line in 3D. So each room essentially represents a floor that you can stop on, and so with this building, there's some mezzanine levels, so you have some floors where you can get out on an elevator, and others that kind of skip that because it's a mezzanine and there's really no floor there to get off on. But also, this other elevator on the left here doesn't even go as high as the elevator on the right. And so that's done programmatically, which makes things a lot more efficient. So here's some screenshots of the actual mobile application. At its core, it's a basic floor plan viewer. You can select any floor to view, and it'll show you the floor plan for that. We have some basic symbology for bathrooms and stairs and elevators and things like that. And then you can also search for points of interest or rooms, and it'll provide navigation room to room across campus. We also have some other settings for things like avoiding stairs. We're hoping to be able to enhance this with ADA accessibility routes. We don't have the data for that right now in the system, but we do have a group that's interested in trying to collect that data to make it available, and then we can have an actual accessible route capability within the application. So this is an application that we bought from GIS Inc. Indoors. We do all of the data on the back end, and all of the data comes from live web services from our servers. We also have an HTML application that's designed as a kiosk mode. So it allows you to specify through the URL the actual location, spatial location of that kiosk. And then anytime somebody does a search, it'll automatically provide a route from that location to their destination. Most of this will probably be used, we think, kind of just within the building, but it'll also allow you to go to any other building, any other room on campus. So let's take a look at the app. So here it is running in an emulator. You can zoom in. Controls are a little weird in the emulator. And I can do a search for, let's say, Smith 209. And so here's all the results that match Smith and 209, and most of these are just 29. Most of these are just rooms 29 in other buildings. So once I've got that, it's a little slow. I think I need to wake it up. Yay, live demo. But I can also set this as my starting location. And I think it's crashing on me. Of course. Okay, well, the other thing I can do is just I'm going to go to Smith 401. And of course, everything's crashing on me. Yay, live demos. All right, well, let's ignore that. So let's go into the kiosk mode. So again, I can search for a room, and this may not work. Do part analysis, that one should work. There we go. So this one is, default location is just kind of the center of campus, and it'll walk me through the routes to get to the individual floor. So hopefully we'll get that released here in the next, hopefully less than a week or so. So, overall it's a lot of moving pieces, but when you break it down piece by piece, it's really not that bad. We have some source data that has to be processed. It's processed through the sync engine, which also derives additional data. It's then put into the actual database itself, and then we can use a variety of interfaces, native GIS desktop stuff, custom applications, third-party apps, a variety of things. The one thing that really doesn't support interior space right now that hopefully will change in the future is kind of the ArcGIS Online platform, and making that kind of floor aware so that you can do the easy filtering by floor in an online environment out of the box. And then of course being able to publish that to the public if you need to. So that is kind of the general overview. Like I said before, the FISDM and the connections between the source data, the processing, and the database are really the foundation, and having those floor plans and a base map provide the foundation to do virtually anything. So, what other stuff could you do with it? Well, it really depends on what your needs are. One of the things that we've been looking at is integrating our fire alarm CAD drawings. We have a computerized system that connects the fire alarm CAD drawings to a database of information similar to like a CAFM system might. And so we can take that fire alarm data from those CAD drawings and process that through, and those have the same spatial location as the floor plan, so they align correctly. And then we can do similar things in a desktop environment, and then ultimately be able to push that out to mobile applications for emergency responders or the Emergency Operations Center for planning or response. One thing that I think is really interesting is being able to produce an emergency evacuation map book. We have emergency evacuation maps on campus that are of a generation from back in 2000-ish, based on Adobe Illustrator files, and I'm not sure where they got the source data for that, but we don't have access to the raw Illustrator files anymore. So making updates to the emergency evacuation maps is really difficult and time consuming, and they're probably not updated quite as frequently as they should be because they're so difficult and expensive to maintain. But the other thing that we found was that there were some inaccuracies in them, not just in the actual layout, but even like north. Some of the maps had north in the wrong place. In an Illustrator environment, it's just really hard to make sure you know really where north is. And so by using GIS, it's inherent in how the system works, so you don't even have to think about that. You just drop your north arrow in your map, and it's going to point north all the time. But we can also do things like provide context, so we can have other buildings, we can bring in some of the base map layers, as well as do an overview map that shows the assembly points relative to the building. And those are kind of elements that our current evacuation maps don't have. And so we're hoping to be able to do this sort of project to expand our capabilities to produce printed maps, not just electronic maps. And of course, anytime anybody needs an up-to-date map, all of the content is maintained from a variety of sources, but they just go to the map book and say, I need this map, and they hit print, and then go hang it on the wall. So, time for some pretty pictures. And I've got a little bit of time, so there'll be quite a bit of time for questions and answers, and I'd be happy to show anything else that anybody's interested in. So this is, we started with interior space from the perspective of space management. That was the source of our entire GIS beginnings. So being able to do thematic reports for space management is kind of what we do at its core. So this is a map book of a thematic map of rooms by department, and they are all spatially aligned perfectly together. Their floors change shape quite a bit, but if you look at the core, they actually do align quite well, and they are rotated to match the building, not true north up. But the tilt rooms that I was talking about earlier, this is how we use the isometric view of the rooms to be able to get a sense of overall space allocation throughout an entire building. And that's one of the things that you can easily lose when doing individual 2D floor views. With a little bit of math, this could easily be converted from an isometric view to a grid view. So you'd have, all the floors, 2D, but kind of stacked vertically or in a grid pattern. There's a variety of different options with that. And that's also just part of that derived data set. There is only one source for a room, but it can be represented a variety of different ways. So a while ago, I put together some prototype space reports trying to combine 3D and 2D and some charts and reports. These ended up being just sort of not really sustainable because of the inability to integrate 2D and 3D and graphics in one interface. I think these were using InDesign to bring it all together. But hopefully with the new ArcGIS Pro, we'll actually be able to do a multi-view page layout that will be able to have all this kind of data together as one map. So we're looking forward to that. And Steve Grisey with Vertex 3 had been playing around with ArcGIS Pro as well during the data translation and QA process, and also looking at ArcGIS Pro and just wondering, hey, what does it look like? And so he's able to send me over some of these images of, you know, rooms extruded and color-coded. I think these are searching for rooms of a particular size, so anything over a certain size or colored, I don't really know. They're just pretty to me. But because Pro does have a world topography map, you do get true elevation stuff in there to go along with it. And I am done early, and I have lots of time for questions. I do have a variety of links and resources on my GeoNet page. I put a post up there with a bunch of links, including the floor plan GIS code and a video, as well as the FME user conference video that really goes in depth about Gizinta and the sync engine. So, Lauren, I'll hand it back to you.
Well, thank you, Aaron. Thank you for showing off some of that stuff. I know the elevation picture you showed last, it looks to me like some faraway place in a far-off land. Yeah, that one.
Exactly. That's actually the Harborview Medical Center. We do some administrative work with them, and so we actually have all of their drawings in our system as well.
That's good. That's really neat. I like it. I like
in the background.
The colors of it. I know you were showing off some stuff the other day and showing different thematic versions of the map with the information, and one of them that stuck was the elevation maps. So.
Oh, yeah.
Yeah, so thank you for sharing that. I think it's interesting the way you do choose to do it with like the CAD and then bringing that into the GIS world with your scripts. I wonder if you can talk a little bit about how you use programming and scripting to integrate into your workflows.
Yeah, well, programming is really one of the most central things to everything that we do. We don't have a lot of staff. I have one CAD drafter, I have one GIS analyst, one person that does the CAD compliance reviews, and then myself, and then we have a couple of GIS interns that mostly work on project stuff, and a temporary project manager. But there's not really a lot of people to do production, you know, day-to-day update sort of stuff. So we really have to rely on programming and automation very, very heavily. And so everything that we can think of to automate, we try to find a way to automate it just to make things work faster. So the floor plan GIS code that I wrote because we don't have a traditional CAFM solution like AIM or Archibus or any of those sorts of things. We just have a raw CAD environment, and so I needed to be able to do some error checking in the CAD environment. So the script that I have will do things like validate that the room numbers are unique in the CAD drawing, that there is a room boundary for every room number, if there aren't, trying to think of what else there might be. There's a variety of different error checks that happen, but then every time, and that happens every time the CAD user hits save. So they don't have to go through and try and think about, oh, I got to make sure I run the script. It's actually built into every time they hit save. The script will see if that CAD drawing is a floor plan, and if it is, it'll automatically run the validation, and if it passes validation, then it'll do a bunch of other work to write those feature classes and create the data in those feature classes to prepare it for GIS. Did that answer your question? Hello, Lauren, are you there?
Yeah, I'm here. Sorry. Forgot to unmute myself.
Oh, I hate that.
Yeah, that does make perfect sense. And so my understanding is that you have the CAD, and the CAD is the base and the source for your information. And then you use the scripts to see where the CAD has changed, and then bring those changes into the feature class environment to harness the power of GIS. Is that correct? Well,
it's actually, we use SQL to be able to compare the what's coming in and what's already in the system. And SQL natively understands geometry as well as data. And so we can actually interrogate the two and compare them and find the differences. And so those differences basically create a change log of what changes need to happen to the production database. So we don't have to, our old system, we would actually delete everything for that floor and then add in everything new. But now, because we're using SQL to interrogate the differences, we can just have those differences running the update. And so that's just a matter of trying to think of, Steve could talk about this for days and days, I'm sure. I try to stay away from it. I know generally how it works, but I don't write all the code myself. But basically, the Python script runs to find any CAD drawings that exist. I guess I should probably clarify that a little bit. So on the server, our document management system will download any drawings that have changed since the last time the process had run. So we do a master download once and then transfer everything or translate everything, and then after that's done, it deletes all the CAD drawings. So if we make a change to 2 CAD drawings, the next hourly process will see those 2 CAD drawings have changed. The document management system will download those onto the server, and then the process will look for any CAD drawings and will only find those 2, process those, and at the end of the processing, we'll actually delete them. And so if there haven't been any changes in the last hour, there won't be any CAD drawings on that server at all. And so that's how it knows what CAD drawings to process. And the document management system inherently understands when things change. It doesn't know what has changed. It doesn't know per feature what has changed. For that, we rely on the SQL comparison of the new and the production to figure out what's changed feature by feature.
Gotcha.
Does that make sense?
It does. That'd be cool to see your workflow too.
Yeah, and actually, the video that Steve has, he shows it running live, and it works great, and it's a really good video.
Pretty. Okay. Very cool. Very cool. Yeah, I think that's great that you can automate things. Like where there's a will, there's a way, and then it's saving so much time for you folks. It frees up more of your time to do other things. Yeah. That's great. Well, I do have a compliment and a question from Graham Smith. He said that's what they're looking for. Great job, and he's impressed. And then his question is, for what reasons do you still maintain floor plans in the CAD format and not move completely to the GIS? And I know you mentioned this a little bit at the beginning as well, like the reasons for some of the functionality of CAD that's not in GIS. But maybe you can talk a little bit more about your reasoning.
Yeah, well, just for one thing, we do capital projects all day, every day. Those projects need to have a CAD drawing to start with. At some point it might be BIM, but we're not quite there yet. So we're able to provide those CAD floor plans as a starting point. We also have a lot of other groups on campus that are still using CAD to manage a lot of other data sources, and they use those floor plans as a background reference. Just the editing capabilities in CAD are, in my opinion, so far superior to what's possible in GIS. It would take 3 or 4 times the number of staff to be able to do the same edits in GIS as it does in CAD. There's just better tools, in my opinion, and we could do a lot more automation that it's really difficult to do in GIS. But we really do need to have those CAD files for a variety of other purposes. So it allows us to have our CAD drawings and leverage the resources and knowledge that we already have for our staff, but also be able to get GIS essentially as a free output. There isn't anything that anybody has to do to say this needs to be translated to GIS. Just the natural process of updating a drawing and putting it in the document management system is what triggers the entire event. So it just ends up in GIS automatically. Mm-hmm.
Makes sense. You mentioned BIM briefly and considering moving to that in the future. We do have a question from Mona Simoin. in regard to BIM, how do you handle the conversion to GIS? Like, do you get products coming in the BIM format that then do need to be converted? Do you take them to CAD first and then to GIS? How do you handle those, or is that even something that you are needing to handle at this point?
It's a very good question. From the project perspective, there's definitely a lot more being done on BIM than we are from an operational perspective. We don't have as robust of a BIM standard as we would like. It's on our to-do list, but we're just not quite ready for that yet. So there's a very uncontrolled environment that's happening right now on our projects in regards to BIM. We do get those models as deliverable, but they're generally in a format that isn't really usable for our needs. We do still require all the CAD drawings, and so we usually do a bit of copy and pasting or splicing of the project drawings into our master floor plans, and CAD is currently our true production environment. We've got some buildings that we've converted over to Revit, and we will do updates to Revit in that. In fact, it's actually easier and faster, but we just bring in the architectural background from a project as an underlay and then kind of draw on top of that in Revit. It's a pretty quick process and definitely much more controlled in terms of a drafting quality standard than CAD is. CAD's, you really have to really work hard to get it right, whereas BIM, you have to kind of work hard to get it wrong. But at the end of the day, what we do is we export that back into CAD, and then the CAD drawings are then processed into GIS. But we do end up having a very high quality output from Revit to CAD. I actually watched a webinar from FME just the other day on some of the new features in, I believe it was FME 2015, as well as some automation to be able to export an IFC file and convert that over. So I'm really excited to be able to get back into that now that I have licenses for the latest software. I'll be able to do that.
Hey.
So
congratulations, license.
Yeah, it took a while. But.
Okay. Well, the next questions are moving into the networking world more so.
Yeah.
I have a question about elevators versus stairs. So, you know, if you're working in a network with driving directions, it takes longer typically to turn left than it would to turn right. And so you take that into consideration when you're doing the network. And so if you're in a building and you start out halfway between a staircase and an elevator, is the system you have right now smart enough to know that there might be a delay for the elevator and then compare that to the diagonals of the stairs going up?
Yes. Yeah, it absolutely does. And that actually is something I didn't quite cover. It was a tip that I got from somebody at Esri, which is really great, is that when drawing stairs, if you draw them all going the exact same direction, meaning like from the bottom up, then you can globally assign cost to those, so that any transition line, so the stairs, have a higher cost going up than they do down. And because the direction is always from the bottom up, you can apply that programmatically. And so we do have costs associated with stairs that are different for going up than it is going down. And then the elevators also have a different speed to them than the stairs do. But we also have the ability to put delays in. So if we have a particularly old elevator that takes just a long time to move, we can actually put delays into the elevator itself to help calculate all of that. We don't have probably quite as much data as we would like to get all of that really well fine-tuned, but it's pretty good.
I love that. I love that. I'm going to be looking that up later. We also have a question from Tom McCaffrey regarding routing. How does it find locations on this multiple floors in the same building? Or let me rephrase this. How does the application find or represent multiple floors on the same building?
How does it represent multiple floors in the same building? So what we have waypoints at stairs and elevators, as well as building entrances. So as soon as the directions get you to one of those waypoints, that waypoint has that floor ID assigned, and so it'll know which floor to show for a floor plan perspective. So if you look at like you're starting at a floor in the lower part of a building, that start of the directions will show that lower floor plan, and then it'll tell you to go to the stairs until you go to like the 4th floor. And once you get the directions that say exit the stairs on the 4th floor, it'll turn the 4th floor on. And so the directions are actually controlling the app to show which floor is associated with those directions.
Okay. And then how does it display multiple floors of the same building, like that offset kind of view that you had?
Oh, the app currently doesn't show anything in terms of a multiple floor at once view. I think it's the tilt view. Let me go back. I think, is that what you're talking about?
Tom, does that look, let's see. I think it might be. Is that a static map you've created?
No.
Okay.
No, it's actual GIS. Let me see if I can fire this up real quick.
All right.
It actually looks really, really terrible if you put like a base map on there, because it's had to spatially move floors apart. So there's one floor that's roughly in the right area, but each floor subsequently is then kind of offset in the Y direction, which makes it look like it's in the Z direction. But as soon as you look at that with a true base map, you kind of you can see that it's actually a purely flat map, and it's just an isometric view. So everything's just been skewed a bit. So let me see if I can grab that real quick. Floor plan. And of course, if I show all of them at once, there's tons of overlap and things. So this is ArcMap. So there's no real Z value information in here at all. What we do is we use that overall building outline wrapper to determine the maximum extent of each floor, and use that that polygon to determine how far to offset each floor so that we don't end up with overlaps. But if I look at, let's do floor ID. Oh no, I want building ID. So here's one building. If I bring in a base map, maybe. Let's just do streets. Sometime today. There we go.
It still looks good on our end. It's still loading everything. Okay.
So, yeah, it doesn't really make a lot of sense when looking at relative to a base map. But that building is actually this building right here. But they're actual polygons, and they have data. So if I look at my identify window, it's got building floor, space ID. I can then link that up with my space data and do thematic mapping in 3D or pseudo 3D. You can't really do a lot in terms of multiple buildings at once because it's 2D and you're going to end up with overlap. I mean, even in this view, it's already overlapping at least 3 buildings. So there's limitations to it, but if you're just looking for an overall sense of the building, this has a lot of value. And you also don't end up with some weird perspective issues that you can end up with if you're using ArcScene. Like this one, you actually have some floor overlap, and the amount of overlap changes from floor to floor because of perspective. So you end up with an isometric view versus a true 3D view.
Okay. Okay. I do have one more quick question on network, and then a few questions separate from that, if we can fit them in. So are you able to navigate between multiple buildings on the same level? So if it's like the first level of two different buildings that are connected in a medical center complex, how do you handle that?
Well, so there's connections laterally from floor to floor across wings. But if you're talking about buildings that are entirely disconnected from each other, it'll tell you to go down to a level that you can get out of the building to go across campus and then come back in. Let me see if this is. Here we go. Okay, so it is working. So here I'm in the basement, and if I go to Parnassus and tell it to route there, it'll have to tell me to go up and out and then to the building and then stairs or elevators, depending on what your settings are. And it's still being slow. But yeah, it does understand where things are in a true 3D spatial location, and it'll have to follow the 3D network to get it back to the ground level and then back up to wherever you need to go. I do have an arc scene view of that.
Ooh, brave person.
I know. Let's go to the other question first, and then I'll see if I can bring this up.
Sure. So there are a few questions I don't think we're going to have time to answer. I'm going to skip straight towards the questions that are asking about your future plans to wrap it up. Eric Whitner is asking if you have any long-term vision for using 3D web or runtime apps internally and to make 3D accessible for the public for use as well.
Yeah, and in fact, I saw a pretty cool demo from Esri, I think they did at the Dev conference, of doing navigation in a City Engine web scene. And so you could interactively pick points on the map, and it would do a 3D route. So being able to do to enable that kind of functionality in a kiosk mode, I think has a lot of potential. Other long-term future goals, we've just barely scratched the surface of what we can do with this. There are very few departments that are actively using this for operational use of managing assets or space or things like that. It's done centrally to manage the overall university space inventory, but we're really just starting to have a conversation about what else could be done with it. Things like life safety and chemical inventories and equipment inventory, emergency response, just day-to-day lab maintenance and management, you name it.
Okay, great. And then the final question is from George Daly. With all of your foundational data in place and moving towards massive integration, what campus applications do you see being created in the coming years and for what stakeholders? So that kind of expands upon the last question as well. Yeah. Are there any specific audiences that you've identified or that have contacted you wanting more?
Everyone, ultimately. But I think life safety is definitely a big one. I think there's a lot of room for improvement there. See, asset management is huge. One of the things that I would really like to be able to see done is be able to start looking at interior utilities like HVAC and plumbing and things like that currently we don't really do much of anything because it's so unbelievably expensive to try and maintain any sort of record of what's current. We have to rely on going back to the archives and kind of piecing things together from archive drawings from who knows how many different projects over the years. I think that there's some opportunity to be able to automate and make it more efficient by bringing some of that into GIS, and that, I think some of that would actually not be managed in CAD anymore, but brought in as a project into GIS and then managed in GIS as a more of a schematic view of the utility versus the architectural layout, which is much more detailed. For operation purposes, the main thing, we don't really need to know how big the duct is, or, well, take it back, we probably need to know how big the duct is. We don't need to have a graphical representation of the exact dimensions of a duct in place. We need to know roughly where it is, what size it is, and where any sort of branching occurs to get to vents and things like that. Or, if it's plumbing, where are the valves. And even that is just, it's about here is really good enough, because they're going to have to potentially, knock a hole in the wall or pop some ceiling tiles to be able to get to things. But it's not like a design and construction environment where you have to know exactly where everything needs to go. Otherwise, you're going to end up with some conflicts, and then the change order is going to get real expensive. From an operations and maintenance perspective, there's a lot lower level of granularity that's needed in order to maintain things versus constructing them. So I think there's a lot of opportunity for utilities in the future.
Yeah, sounds like you have plans in the work already.
Yes.
That's
okay.
Great.
So here is one floor of the network, and you can see that on this floor everything kind of goes up. So the stairs and elevators go up, and that's true for every floor. There's never a floor where things go down. And then if we look at the whole building, we can see that some of the building is below ground, some of it's above ground, and there is kind of a level that's associated with the ground level. And then, of course, we have our exterior network, which are the red lines here, and that allows the bridging of the outside to the inside. And then if we look at the whole campus, you can see that we've got a few things here. Try the base map, make it a little bit more interesting. And I always have to do like a 5 times vertical exaggeration to be able to see this kind of stuff, because without that, it's so compressed you can't see anything. But this is the network that we have so far. It's only about 80% of the campus or so. But if you look down here, and this is our health sciences complex, and there's probably like 6 or 8 different wings just in this area alone, and we don't even have all of them loaded in yet. But there's connections laterally, on a floor that connect wing to wing, which has to be done in CAD. Make sure the CAD floor plans do align, so we have to make sure that the endpoints of the routes from each drawing line up, and the endpoints are coincident. Otherwise, you won't be able to actually make that transition. So,
how cool would it be to be able to show pedestrian traffic flows overlaid with this network?
Yeah.
That would be cool.
There is some really interesting technology out there with location analytics and be able to track people. We're not doing any of that now, but to be able to see traffic patterns, I think the best we could probably do right now is aggregate all of the requested routes and kind of see what are the kind of routes that people are requesting and be able to map those. Mm-hmm.
All right. Well, we are over time, so I'm going to wrap it up.
Okay.
Thank you, Aaron, so much for taking the time to present and to answer questions so thoroughly. If you haven't gotten your question answered already, please do contact Aaron after. I know from personal experience he's very helpful and good at explaining things, and I'm sure he'd be glad to answer any questions you have now or after. Thank you to all of our attendees joining us today. You can access the recording and slides from the CFTA website following this webinar. The next webinar in the Geotech Showcase is scheduled for 1 p.m. Eastern Time on May 26th. Niels Lacour, Senior Physical Planner at the University of Massachusetts Amherst, will present Integrating GIS and IWMS to create an effective space planning tool. For more information on future webinars in this series and more, please visit the CFTA website at www.cfta.org. Thank you.